And let me go ahead and share my screen. All right. All right, welcome YouTube, welcome scholars. So let's see. So this brings us to, we are at the top of week 7. I hope everyone had a great weekend, right? As usual, hopefully you got some rest and we're able to get some work done. So a good mix of doing what you want to do with doing what you need to do, right? Be as balanced as possible. So with this being the top of week 7, that means that we can anticipate exam 2 to become available this upcoming Sunday at 11:11 a.m. It'll be available for 7 days, so it'll be due the following Sunday at 11:59 p.m. Right now, I'm under the impression that this upcoming Monday and Tuesday is fall break. So I probably will send an announcement, but we won't. If it's fall break, then we won't meet.
So do we have an assignment due this Sunday or not?
They still do that Sunday night at 11:59 p.m. Like it's assignments are due weekly at 11:59 p.m. I'm just saying as far as us meeting, like I won't meet, but everything else just kind of clicks like normal.
So
go ahead.
We don't have our midterms. It's the assignment only, or
Just exam. It's not like a midterm exam or anything like that. It's just exam.
Okay.
Yeah.
And it'll be posted today?
No. The exam 2 is going to be available this upcoming Sunday.
Oh, okay. All right.
So let me see. As far as the midterm is concerned, so usually what I do, I try to calculate the grade after exam 2 is due. So if exam 2 is due that following Sunday at midnight, I try to wait until like that Monday morning to calculate your midterms, your midterm grades. It's basically exam 1, exam 2, and then whatever your homework and quiz average is at that time, right? All right. So let me think about what else. Right, and so the midterm grade is just a snapshot of where you are at that moment in time, right? So I know that some students still haven't gotten full access. So, because of the nuances and everything, this is why, I kind of structured the class the way I did, where, we get unlimited attempts. There's only a 10% late penalty, right? So if you're just trying to get higher than a 90, you want to get it submitted on time. Otherwise, the hard deadline is at the end of the week of finals. So that first week of December is finals week. That Friday at 11:59 p.m., that's the hard deadline for everything, right? That first Friday.
Right.
I'm trying to think if there are any other announcements. Okay. So as usual, this is a remote asynchronous, right? So, if you got into the Zoom, you got your attendance credit, you're not obligated to stay. And if you have questions, comments, or concerns, feel free to unmute yourself to get my attention, or you can type in the chat, and I'll check the chat periodically. I'll check Zoom again around the 15-minute mark to get any latecomers. So with the exam 2, today we're going to be wrapping up. Let me do it like this. View single page. We're going to be wrapping up chapter 1. All right. So graphs and functions. And so today we'll be working on section 1.6, combining functions and composite functions. Okay. And so then exam 2 is 6, 5, and 4. So sections 1, 4, 1, 5, and 1, 6. I want to say that generally speaking, math exams are cumulative, right? So like we can't talk about things in sections 1, 4, 1, 5, and 1, 6 without using the material from the earlier sections. So even if I ask questions solely on the second half of chapter 1, again, it's still going to be piggybacking off of the material from the first half, right? Okay, so by default, math exams typically are cumulative. So the objectives here for section 1.6, we like to define basic operations on functions. We like to form composite functions. We like to find the domain of a composite function. We like to decompose a function and apply a composition to practical problems. So in my earlier class, we barely made it into that third objective, right? We got one example where we were able to get to that third objective, right? So, okay. Can we, no, that doesn't work, okay. So we have this thing that says the sum, difference, product, and quotient of functions. Let me go like okay. So let f and g be two functions, then the sum f plus g, the difference f minus g, the product f times g, and the quotient f divided by g are functions whose domains consist of those values of x that are common to the domains of f and g, except where f divided by g, where all those x values that make g of x equal to 0 must be excluded, right? These functions are defined as follows. So we have the sum. Okay, so this guy, this means f of x plus g of x, f of x plus g of x. A common error or a common misconception that students have, they treat this like distributing, like multiplication. This is not multiplication. That's not what's going on here, right? This is function notation. This guy here, this just means f of x plus g of x, right? We're not distributing. I've had where people were making examples to solve an equation or whatever, and they were distributing x, and then that would throw everything off, right? So this is not multiplication. This just means the function f plus the function g. This just means f minus g. Then f times g and f divided by g. And again, we have to exclude any x that makes the denominator 0. Okay. Okay, so let's change my view. Let's add a page. We need it like about 2. Okay. So here we have let f of x equal x squared minus 6x plus 8, and let g of x be x minus 2. For part A, we're asked to do f minus g of 4. So we're evaluating. Part B, f divided by g of 3. C, f plus g of x. D, f minus g of x. E, f times g of x. And f divided by g. Okay. All right. So then again, part A, f minus g of 4. All right. So what this means f of 4 minus g of 4. All right. So basically what we can do here to evaluate composition of functions, we're just going to evaluate when, f of 4 when x is 4. We're going to evaluate g when x is 4 and then subtract our results, right? So let's do like this. So we'll do this one. We'll do it in this color. We'll do g in this color. Okay. So then first, let's go ahead and find f of 4. So we just rewrite f of x like normal, but we're going to replace each x with 4. And again, when I do my substitutions or evaluate functions like this, first thing I like to do is replace each x with a blank set of parentheses. So we're going to have x squared minus 6 times x plus 8. And then what number goes into the blank parentheses in this case? 4. The blank parentheses help us to keep track of negatives, so we reduce our chance of making a mistake with our signs, right? So then to crunch this number, 16 minus 24 plus 8, I think that's what, 0? Okay. Let's go ahead and find g of 4. G is going to be x minus 2. So here's our x minus 2. And again, we're plugging in 4. And I think that result is 2. So then ultimately, f of 4 minus g of 4 ends up being 0 minus 2. And that final result is what? Negative 2. Okay. Copy. Okay. So that was part A. And again, if anything is not clear, feel free to unmute yourself. Let me try to get through part B, and then I'll check attendance and I'll check Zoom again for questions in the chat. So for part B, f divided by g of 3. F divided by g of 3. Okay. This means f of 3 divided by g of 3. Okay. So let's do those individually and then compare the results. So then if we do f of 3, it's going to be x squared minus 6x plus 8. And the x in this case is 3. It's going to be 9 minus 18 plus 8 is negative 1. Okay, so that was f. Let's go ahead and crunch, evaluate g when x is 3. I think g is x minus 2. Or x in this case is 3. So that result is 1. So then f of 3 divided by g of 3 ends up being negative 1 divided by 1, which is ultimately negative 1. Okay. Hopefully that made sense. All right. So those were some examples on evaluating composite functions, right? So composite functions is basically you're just using arithmetic comparing one function to another, like adding functions, subtracting functions, multiplying functions, and dividing functions, right? That's composition of functions. Okay, let me take a moment to, I just want to check Zoom to see if we got any stragglers. Let me, yeah, that's fine. Stop. Let's see. Oh, we got a lot to somebody. So, okay, let's get these guys. Got this student. Look what I can do. Okay, I got this student. Okay, I got this student. And this one. And this one. Okay. All right, the chat looks clear. Let me go back to share my screen. Start the broadcast. If you're just joining us, we are continuing we're closing out chapter 1 with section 1.6, composite functions and combining functions and composite functions, right? So what we've done so far, given a couple of functions, basically we're adding functions, subtracting, multiplying, and dividing functions, right? So we just got through examples for parts A and B. So now we're about to start on part C, f plus g of x. Okay. G of x. So basically, let me see if I go like this. Let's copy. So part C, f plus g of x, f minus f times. So then it's basically the operators. Paste. Undo. Paste. Okay, cool. Okay. So then part C asks us to do f plus g of x, all right? Again, this just means f of x plus g of x, okay? So then that's going to be x squared minus 6x plus 8 plus x minus 2, right? We don't need parentheses here because we don't have anything to distribute like multiplication over addition, so we didn't need any parentheses here for grouping. Then we just combine like terms. So then I think that x squared, that's the only one. We have a negative 6x plus x is going to give us a negative 5x. Then 8 minus 2 is 6. Okay. Okay. So that was C, and then part D, if that's plus, they ask us to do f minus g of x. So again, if you're just joining us, be cautious about this. This does not mean we're not distributing. We're not doing this. We're not multiplying by x. This is a function notation, right? This means, what this means is f of x minus g of x. We're not distributing. I know it's tempting, it looks like it, but if you make a habit of distributing an x, it's going to start throwing off your results. All right, because that's not what we're doing here. That's just how we define. This is defined as f minus g. All right. Okay. So then basically is this guy right here. It's a copy of this. Copy. But instead of it being plus, it's minus. Oh, okay. And because it's minus, we should do this. Okay. So because of the minus, we need to distribute that negative into G. Okay. So then it looks like we get x squared minus 6x plus 8. Then we're going to have minus x plus 2. Then we just combine like terms from that point. So we're going to have x squared. You got a minus 6 minus 1 is minus 7. 8 plus 2 is going to be plus 10. Okay. Ooh, I don't know. All of a sudden, I just got like really sleepy. I don't know. Maybe it's because I ate something. Like I was fine. I ate something and then I got sleepy. I'm like, I mean, and it was like all it was just like peanut butter sandwiches. I was like, why am I so sleepy all of a sudden? Okay, so that was part D. We did F minus G. So then we could do F times. So part D. So then E. E asks us to do F times G of X. Again, this just means F of X times G of X. Okay. Okay. So what I can do, I'm just gonna copy this guy because it's basically the same thing. Let's copy and paste. And then instead of it being minus, it's times. Okay. So in order to say F times G in this context, page, oops, not Okay. So in order to multiply, we essentially need to distribute. All right. So we need to say x times each term here. And then we also need to do this -2 times each term here, right? So then if we do that, it's basically foiling. X squared times x is x cubed. And then minus 2x squared. Okay, then we're going to get minus 6x squared plus 12x. Okay. And then we're going to say plus 8x minus 16. Then if we go, I wrote it in a way so that our like terms should be side by side. So then I think now we combine like terms. So the x cubed comes down. -2 minus 6 is -8. 12 and 8 is 20. Minus 16. Okay. Okay, hopefully I haven't made any mistakes. Sorry about that. Okay, and then so then the last one is D, F divided by G. Let me see D, E, F. We're gonna say F divided by G of X. Again, this means F of X divided by G of X. Okay. So then this is gonna be sorry. Let's see, we got x squared minus 6x plus 8 divided by x minus 2. Okay. Nothing. Oh, wait, we might be able to cancel. So maybe we can factor the numerator. Can we factor it into some form like this, where we have x and x? Two numbers that multiply to give us 8 and add to give us -6. I think it's what? -4 and -2. Thank you. -4 minus 2. -4 times -2 is +8. -4 plus -2 is -6. Okay. And this is still divided by x minus 2. Okay. So then we should be able to see that this is going to be canceled by this. And the result here is going to be x minus 4. But we do have to acknowledge that x cannot be equal to 2 because it makes a 0 in the denominator in the original part. Okay. All right. Yeah, it's just like all of a sudden I was going good and okay. Let me see, A, B, C, D, E, F. Okay. So these are the results that we got. All right. Let's page. -2, -1. X squared minus 5x plus 6, x squared minus 7x plus 10. Okay, let's see. Okay, -2 and -1. You see here's a type version. X squared minus 5x plus 6. I think that's what. Yeah. Okay. Okay, I think we got all of these results. Okay. So, composition of functions. So if f and g are two functions, the composition of the function f, like this, the composition of the function f with function g is written as this guy here, f composed g. And is defined by the equation, again, f composed g of x means f of g of x, right? Where the domain of f composed g consists of those values of x in the domain of g, for which g is in the domain of f. So this notation, f composed g of x, what it means is the second function inside the first function. The second function inside the first function. Okay. And then when we go to find a domain of a composite function, sorry, give me a moment. Yeah, okay, sorry. So when we go to find a domain of this composite function, there's a 3-step process. I'll go more in detail about it when it arises. But there's 3 steps that I usually do to find the domain of a composite function. Okay, and we'll talk about it momentarily. And this is just like a correspond or just a mapping showing you, how, just the flow when we do composition of functions. So when we're considering f composed g, again, it's the second function inside the first function. So then this is going to be the domain of g because we're starting with a set of input values. We're passing them through g. And then the output is going to be g of x. Then whatever answers we get there, we're passing those through f. And then the output is going to be f composed g. Right? So then this guy ends up being the domain of f composed g. And then g of x must be in the domain of f, okay? So this is just like a diagram. You can essentially ignore this. And when we work an example or two, you'll start to see how it sinks in and how we navigate this, right? Let me see, so let's start here. We have f of x is this guy, and g of x is this. We're asked to find the following, okay? Let me give myself some space. Oh, did it crash on me again? It keeps crashing on me. Okay. Give me a moment. I might have to reboot this part. Come on. Okay. I can leave it in this mode, actually. So we checked all of that. We talked about that, and we left off here, and we need to add. I think we only need like 1 page. Okay. So here we have what? F of x equals x cubed. G of x equals x plus 1. For part A, we're asked to find f composed g of 1, B, g composed f of 1, and then C, f of f negative 1. Okay. All right, so for part A, f composed g of 1, this means the second function inside the first function, f of g of 1. Okay, so let's find g of 1 first in this case. Let's evaluate g of 1 first, and then take that answer and pass it through f. So then g of 1, that's going to be x plus 1. Again, x is 1 in this case, so it's going to be 2. So then we're going to take that and pass that through f. So then this is going to be equal to f of 2. So we just took that answer and now we're passing it through f. Okay. So then if we want to consider f of 2, f is x cubed. Cubed. And again, our x in this case is 2. 2 times 2 is 4 times 2 is 8. So then f of g of 1, that result is 8. All right. Let me finish out this example. Let me see my time. AB. G compose f of 1. All right, so I think we're reversing the order. This means the second function inside the first function. So this means g of f of 1. Okay. So let's go ahead and evaluate f of 1. It's just x cubed. So there's going to be 1 cubed is just 1. So then we want to do g of 1. Okay. G looks like it's x plus 1. So then g of 1, we said it was what? X plus 1. So I'm going to put a 1 here. So the net result ends up being 2. Okay. Now, I feel like there should be questions. Let's go ahead and do part C. Part C was f of -1. F of -1. This means the second function inside the first. This means f of 1, f of -1. So then this is going to be, what is that, 1 cubed? So it's going to be f of -1 cubed. So then that's going to be f of -1. And I think we just did that, right? We just found f of -1. So then that means this result should just be -1. Okay. I feel like there should be questions, but it's okay. This is a safe space. I totally get it. That's why I encourage you all to work together, to link up with your tutors, to ask for support. This kind of stuff usually gives most students a difficult time. Let me see. So 8, 2, and 1. We got 8. You see the 2 and -1? Yeah, -1, right? I think we got -1. Yeah. Okay. So let f of x be this and g be that. Find each of these. Let me see the time. I might, okay, because we're kind of short on time, and I do want to kind of mention this other one. I'm going to say see my recording for this one. So I'm going to say see the link for recording. Just because of 6 time, we got like a few minutes left. I want to work on the next one. I'm gonna let that be. Yeah. So since my earlier class did part A and that recording is available, let me go ahead and do part B because they should be about the same, right? So part B says find G compose f of x and its domain. Okay, so we're gonna start there. If you want to see part A, it's at least 2 versions. There's one I did this morning, and then there's one in the pre-recorded session that you can check out. So then if we want to evaluate, we want to find G compose f of x. Okay, we see our f and g at the top of the screen. So this means G of f of x, the second function inside the first function. Okay. So then this means G of, now f of x is x plus 1, so this is going to be G of x plus 1. So then what we're doing is we're going to write G like normal, but then we're going to replace each x with the fuchsia thing. So then this is going to be 1 over x, but then again, we're replacing x with this x plus 1. Okay. Okay, so I just want to say this part on the domain of a composite. I'm kind of out of space, so let me get myself. So there's a 3-step process. Oh shoot, it probably froze again. Ugh, come on. Hopefully we didn't lose our work. Yep. Uh-oh. Okay. I think we're okay. Yeah. Here it is. Okay, let's add a page. Oh, did it freeze it again? Okay, I was like, come on, I need you to work. I see the time. I'm trying to wrap it up. Okay. So this is G compose F. Now for the domain, let me see, can I paste? So for the domain of a composite function, there's a 3-step process that I do. I'm going to take some notes here and call it domain of a composite. Okay. So the first suggestion is, let me see, find the domain of the inside function. Secondly, we want to find the domain of the simplified function. Find the domain of the simplified function. And then the third step is to take their intersection. Okay. So in our example, the inside function is f of x. Yeah, for part B, right? So f of x, that domain is all reals. So then again, for domain, so for our inside function, that's going to be the domain of f, and that just happens to be all reals because f is like a line. So the domain of a line is all reals. So the domain of f is going to be negative infinity to infinity. Okay. So then the domain, next we want to find the domain of the simplified function. So that's the 1 over x plus 1. So we're going to say the simplified. So if we're evaluating 1 over x plus 1, we have to scrap any x that makes the denominator 0. In this case, it would be -1. So we have to throw out all numbers except -1. Okay. So I'm gonna leave it like that for now, just for the sake of time. And then the third part is we want to take their intersection. Okay. So we want to say all reals intersect everything except -1. So the whole line intersection is like, what do these two sets have in common? Well, these two sets have every point in common except for -1. All right. So then all reals intersect x not equal to 1. It's ultimately just going to be x not equal to -1. All right. But then we need to write that in interval notation. So let's look at this graph. Say we're on a number line and we consider -1. If we want everything except -1, that means we want everything to the left of -1. We want everything to the right of -1, but -1 gets a parentheses like this because we don't want to include -1. All right, so that's the graph. So then the interval notation is going to be like this. The far left is going to be -infinity up to -1. And then we're going to say from -1 to infinity. Infinity always gets a parentheses. In this case, because we don't want to include -1, it also gets a parentheses. And then because we're saying the solution consists of any number from the left-hand set or the right-hand set, so we combine it with union. This little weird you may have seen by now. Okay. Undo. Let's copy. And this was our interval notation that we got, okay? So that was a demo on the 3-step process for finding the domain of a composite function. See the time? Yeah, I'm glad I skipped this. Because I at least wanted to mention this. Let's go to the view, single page, all right? So that was on the domain, that 3-step process for finding the domain of a composite. And we got 1 over x plus 1. Okay, so let's compare it to type notes. 1 over x plus 1, everything except -1, okay? I feel like there should be questions. Let me pause for a moment to give you an opportunity to ask questions. While we take that pause, let me go ahead and load a copy of this. So I'm gonna make a copy of this PDF, all the stuff that you saw me writing. As soon as I finish this, it'll be available and you can pull a copy of it. So if we go to notes, update it daily. Yeah, thank you. This is week 7 at 2 p.m. Okay. When that bar finishes loading, you get a copy of it. Okay. All right. So all right. So if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. All right. See you Wednesday, same time, same place. Take care. Peace.
Thank you.